Good morning, or maybe it's the afternoon for you, but it's the morning for me, Calculus 1 students. First of all, welcome to my YouTube channel, and welcome to the Calculus 1 playlist. So this is the first problem that I'm gonna ask you to watch as an assignment. Okay, now one thing that you can do if you want, okay? We haven't seen a lot of examples yet, but if you want to try this exercise by yourself and find out a solution, that's great. Okay, this YouTube video is here for you to check your answer. Otherwise, if you don't have the time or if you're not comfortable yet in solving this kind of limit, you can also just watch the video, follow along, and it will provide you like a step-by-step explanation. Okay, so let's evaluate this limit if it exists. Okay, so we saw that the limit could exist or not exist, but we saw more than that. We also saw that if it doesn't exist, it's actually meaningful information to determine if it's going to infinity, negative infinity, or neither of those, right? Or it just like doesn't exist for another reason. So let's look at this limit. So what we do first is we replace x with 0 and see what happens. We're going to see later in the course that this is called direct substitution. So step number 1, so we have the limit as x is approaching 0 of x minus cosine of x over x squared. And we just pretend, right? We see, okay, so if x is equal to 0, what happens? We have 0 minus cosine of 0 divided by 0 squared. We already see that there's a problem at the denominator. So now I'm going to use red. Okay, so there's a problem at the denominator. Let's have a look at the numerator. We have 0. Cosine of 0 is 1. So that's what we get. We get negative 1 over 0. So what does it mean? It means that the limit does not exist. First of all, it means that. But the problem is that now we have to distinguish between these three possibilities. So I will write that. The limit could be, so infinity, negative infinity, or does not exist. Okay, so we have to determine which one of these three possibilities we have. So what we have to do then is we have to do the two one-sided limits. So we have to do the limit as x is approaching 0 from below, and we have to do the limit as x is approaching 0 from above. If they agree, we will have one of these two. If they don't agree, we will have to write does not exist. So limit as x is approaching 0 from below, so same limit, cosine of x over x squared. And now we're using notation, right? But that notation just means something really precise. So first of all, the top, don't worry about it. You know it's going to give negative 1. You know that the top is going to approach negative 1 as x is approaching 0 from below. Now let's have a look at x squared. So what's going to happen? We're going to write, okay, so first of all, this notation, what does it mean? What it means is that x is approaching 0 from below. So x is approaching 0 from below. Okay? But as we, so basically, so it passes by negative 0.000 all the way down to, you can put as many zeros as you want, and you're going to get like a negative number. But as you square this, it's going to approach 0 from above. Okay, so the reason I write 0 from above here is because as x is approaching 0 from below, x squared is approaching 0 from above, right? Because it's going to passes by, and let's put, for example, negative 0.000 all the way down to 1. As you square this, you're going to have even more zeros. So, and you're going to get like a positive one. Like you're going to have a positive number, sorry. Okay, so you're going to have even more zeros, okay? It's not going to be the same number of zeros. The idea is if you square a negative number, you know that you're going to have a positive number. And now you look at the overall sign. So you're going to divide the negative number by a very, very small, a number that's approaching 0, but that stays positive. So this overall limit, like this overall factor over here, this overall function is going to approach negative infinity. That's for the limit from below. We also have to evaluate the limit from above. So limit from above, as x is approaching 0 from above, of x minus cosine of x over x squared. Okay. So, okay, same idea. We know that the top is going to be negative 1. The bottom, now, whenever you write something like this is what I'm expecting you to write on, let's say, a test paper. But you don't have to provide these explanations, right? This is only me explaining the problem. So here it's the opposite scenario, but you're going to see that it comes to the same conclusion just because of the squaring, because as you square a negative, you get a positive anyway. So first here, x is approaching 0 from above. So for example, it passes by 0.0000, put as many zeros as you want. It passes by this number. Okay? And then, as you square, you're going to get negative 1 over 0 plus. So basically, what I want to say here is that as x is approaching 0 from above, x squared is also approaching 0 from above. Because as you square a positive number, you also get a positive. So it passes by 0.00 all the way up 0.1 squared, which is the same as 0. Well, you put even more zeros in some way. 1. Okay, like this, let's say. So it means that you have the same conclusion. You have negative 1 over 0 from above. That's going to negative infinity. So as a conclusion, since these two limits, since the limit from above matches the limit from below, you have to conclude that the correct answer is negative infinity, right? We had the choice between these three. The right answer is negative infinity. So you would conclude just by writing the limit again and say that, okay, well, this limit is equal to negative infinity. I hope this helps. See you either in class or in the next video.